Have you ever wondered why the universe, with all its vastness and complexity, doesn't just collapse in on itself? The answer lies in a fundamental principle of quantum mechanics known as the Pauli exclusion principle. Imagine a crowded elevator. Everyone inside has their own personal space, and no two people can occupy the same spot at the same time. This is a simplistic way of understanding the Pauli exclusion principle. In the quantum world, particles known as fermions are like the people in the elevator. They each have their own quantum state, and no two fermions can occupy the same state at the same time. The principle was formulated by physicist Wolfgang Pauli in 1925, and it's a product of the wave-particle duality of electrons and the uncertainty principle. Electrons, like all quantum particles, exhibit both particle-like and wave-like characteristics. Their wave nature results in spatial spreading, which means that if two electrons tried to occupy the same quantum state, they'd experience destructive interference. In other words, they'd get in each other's way. To avoid this, the Pauli exclusion principle simply states that it's not possible for them to be in the same state in the first place. Another way to understand this principle is through the uncertainty principle, which says that it's impossible to know both the precise position and momentum of a particle at the same time. This inherent uncertainty in the electron's location means it can't be in the exact same spot as another electron. The Pauli exclusion principle's influence stretches far beyond the atomic level. It's crucial for the stability of matter, preventing atoms from collapsing into themselves. It also impacts the formation of stars and galaxies, dictating the structure of their cores and the distribution of their constituent elements. This principle also helps explain some of the most fascinating phenomena in quantum mechanics. It gives us insight into the superfluidity of helium, a state where liquid helium flows without any viscosity. It also contributes to our understanding of antimatter, particles that have properties mirroring their ordinary counterparts. So to summarize, the Pauli exclusion principle is fundamental to our understanding of the quantum world. It shapes the behavior of matter and helps us make sense of a range of physical phenomena. Its influence stretches from the microscopic world of atoms all the way to the macroscopic scale of stars and galaxies, making it a foundational principle in our ongoing exploration of the universe.